Hello, this video is going to be about the binomial model. So let's get started and um, talking about the binomial model. We have to start with the definition of what the random variable is. Okay, so if we have a binomial random variable, if we have a binomial random variable, okay, the 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 collection of all these random variables will make up the model. Okay, because remember, a binomial probability model, or a model, is basically just a collection of all the random variables with each respective probability of that random variable happening. So by a random variable, we'll call it capital letter X, okay, is the number of successes in so many trials. In so many trials. Okay, so it's the number of successes in n trials. So before we go any further, we have to talk about these trials for a second. Okay, because they have to follow a specific guideline. To be a binomial, these trials have to follow um, some rules. Okay, and these rules are called, or these trials, they have to be called, or they have to be Bernoulli trials. They have to be Bernoulli, Bernoulli trials. Okay, and so what that means to be a Bernoulli trial, what happens is for each trial that we observe, there has to be a success or a failure. Okay, there has to be a success or a failure. So say you're getting up to bat, you either could get a hit or you won't get a hit. If you open a box of cereal, you either get the prize or you won't get the prize. Okay, so that's sort of the example. There has to be a success or a failure. Okay, so the next condition for a Bermuda trial is the probability the probability of one trial the probability of one trial is equal is the same as the next trial, and so on. Okay, so the probability of every trial has to be equal. Okay, that's basically what this says. The probability of every trial has to be equal. And the last one to be a Bernoulli trial is that each trial has to be independent. Each trial must be independent. And what does that mean? The first trial happening can't affect the probability of the next, can't affect the chances of the next trial happening. So if the first trial happens, the second trial can't be, the probability of the second trial can't be increased or decreased in any way. Okay, so to be a binomial random, to be a binomial random variable, it has to follow these three things. Okay, and there's one more thing that it has to follow is the number of trials must be finite. There must be a finite number of trials. Okay, and generally we call trials by n. N is usually the number of trials. Okay, so to be a binomial random variable, or to be a binomial random variable, these four things have to be met. Okay, and then once you start seeing problems, you'll get comfortable at knowing which is what. But it's very important that you really understand this formula, or this definition right there. The number of successes, the number of success, and n trials, or out of n trials. Okay, so let me just give you like an example how some of these could ask. So they could say a baseball player could get up to bat 10 times. To bat 10 times. So each time would be considered a trial. Okay, so now say, what's the probability that he gets 3 hits? We've kind of been doing problems like this. What's the probability he can get 3 hits? Okay, so basically what this problem is asking is saying, out of 10 times, okay, out of 10 times getting up, what's the probability you're going to get 3 hits? So if he gets 3 hits, then he's going to miss 7 times. So that'd be 7 misses. Okay, so if we look, we could say, okay, for every trial, so here would be the first trial. Is this a success or a failure? Yes, he's either going to get a hit or a miss. The second trial, he's either going to get a hit or a miss, and so on, up to 10 trials. Okay, the next thing is the probability of one the same as the next one. So we're going to assume that every time he gets up to bat, he has the same chance of getting the hit. So let's say the probability he's going to get hit, the probability he gets a hit, this has to be given. Okay, the binomial models are sometimes written like this, with a B and an N and a P, because they have to give you two things. They have to tell you how many trials, which they did here. They gave me N trials, and they have to tell you, if they say what's the probability he's going to get 3 hits out of 10 tries, they have to tell you what the probability that he's going to get a hit on any given trial. Okay, so let's just say he has a 28% chance of getting a hit. So the probability for each time would be that he would get the hit would be 28%. Okay, so that would be true. Each trial must be independent, so the chance he gets a hit the first one can't affect the chance he gets a hit on the second one. Sometimes the second one will make this third one true, or the third one true will make the second one true. If they're independent, then that doesn't change the probability of every event. Okay, so that's kind of like an outlook of how these problems are all going to start looking. So let's look at this model here. Let's go ahead and then we'll set up a model, and then I'll end it there. And then the next video will show a lot of problems. So let's talk about the hitting problem, and we'll set up the table. So let's say a player gets up to bat 5 times. Okay, he 5 tries to 5 tries, or 5, we'll call them at bats. Okay, so let's say we're going to define X. X is the number of hits in those 5 tries. Okay, so let's set up a model. So if you ask yourself, if he gets up to bat 5 times, 5 tries, 5 at bats, and X is the number of hits in those 5 tries, what are all my possible random variables? So let's set up a random variable table, just like before. It's the same thing as before. If you're in my class, you should be kind of used to these things. If not, then that's okay also. What are the possibilities that could happen? Okay, what are my possible random variables? Okay, so he gets up to 5 times. What happens if he doesn't get any hits? And that would be here. That's a possibility. X would equal to 0 hit. What's the probability he gets? Okay, what could happen? He could get 1 hit. Okay, so this could be 1 hit. He could get 2 hits. He could get 3 hits. He could get 4 hits. And I'm missing 1 here. He could get 5 hits. Okay, so X is the number of hits he gets in 5 tries. So this is a binomial random variable with 5, and the probability, we'll keep it at the same. He has a 28% chance of getting hit. So I have 5 trials, and this is the probability, which we call P, the probability of a success. Okay, so we've worked with these, and you could actually find 2 of these already. Okay, you should be able to find 2 of these. You should be able to find this one and this one. And if you're not sure, this is the notation. What's the probability that X this will probably get no hits. Okay, so let me instead of jumping real quick, let me write them all out so we could see it. So 1, 2, 3, 4, 5. Those are my 5 tries. So we'll call hit will be an H. This will equal a hit. That's the event he gets a hit. So the first time he gets to the bat, this would be no hits. No hits. So the first time he gets up the bat, he doesn't get a hit. He doesn't get a hit. He doesn't get a hit. He doesn't get a hit, and he doesn't get a hit. C means complement. Okay, if you're just seeing this, this means no hit. Okay, so the probability he's going to get a hit is 28%. So the probability he's going to get that he's going to fail is 1 minus 0.28, which would be equal to, let's say 7 and 2, 0.72. So the probability he doesn't get a hit would be 0.72 times 0.72. These are all 0.72s. So this is going to be 0.72 to the 5th. Hopefully you guys saw that. See, I saw it here because I could see if he gets hits every time. This means 1, 2, 3, 4, 5. This means here that he gets all 5 hits in 5 tries. Okay, so this would be a hit, a hit, a hit, a hit, and a hit. So this would be 0.28, 0.28, 0.28 all the way, 0.28. So this would be 0.28 to the 5th. Okay, so what we need to work on is how do we find these? How do we find these individuals? How do I find the probability that x is equal to 1, or the probability that x is equal to 2, or the probability that x is equal to 3, and so on, and x equals to 4. Okay, so I'm going to do a different video on that one because to find these probabilities, it's not difficult, but it's just going to take time, and to limit the time on these videos, I'll do that one separately. Okay, so that's a little introduction to binomial, and we'll be getting a lot better at these as we go. We're going to do a lot of examples, stuff like that. So thanks for watching.